Hello students, welcome to the lecture on supply chain restructuring, and after this lecture we will be able to learn the following objectives. Discuss supply chain mapping, explain the supply chain process restructuring, define the postponing the point of differentiation, describe the re-engineering improvement in SCM, explain the steps to re-engineer the process, discuss the improving organizational efficiency. Let's start with a brief introduction. The restructuring activities of the type mergers and acquisitions M&A constitute a real challenge for the companies competing with the ones involved in M&A processes. As such, a restructuring process usually improves the resulting company's position on the market by creating or consolidating a competitive advantage. The competitive advantage takes the form of reducing overall costs by economies of scale, access to new markets, access to new products or technologies. Supply chain restructuring focuses on these innovative practices that separate leaders from the also-ran companies. Unlike supply chain integration and supply chain optimization, supply chain restructuring goes beyond supply chain function and requires integrating product and process engineering with supply chain function. Similarly, it may also involve closer integration between marketing and supply chain function. Let us now discuss supply chain mapping. A supply chain map is a graphical representation of supplier network or selected supply chains. Maps can either be geographical or an abstract network design. As supply chain network structures become more complex and geographically dispersed, management can benefit from developing a relationship-based map of their company's supply chain. The visual representation and analysis of the complexities in a firm's direct and indirect supply chain relationships serves as a starting point for increasing the cross-functional and cross-firm communication that is necessary for implementation of the supply chain management processes. The mapping effort also enables management to identify internal and external improvement opportunities and establish the critical relationship linkages that must be closely managed. The authors suggest that not only is there a need to visualize the supply chain, there needs to be a well-established process for building the map so that knowledge is easily transferable and exchangeable among managers and organizations as appropriate. Further, the map should link to the strategic planning process of the firm to facilitate evaluation of supply chain membership and structure. Before an effective supply chain mapping process can be developed, it is important to understand the nature of maps, the importance of supply chain mapping, the role of supply chain mapping in strategy, and characteristics of supply chain maps. Supply chain mapping is further distinguished from process mapping or network design. Characteristics of a good map are described based on review of the cartography, logistics, and supply chain literatures. The risks of producing a supply chain map are examined since putting potentially sensitive data out for broad viewing has internal and external risks. A clear link from map building to firm and supply chain strategy development is proposed. Finally, future research is recommended to develop mapping approaches and conventions for use in supply chain management. What is a map? There are a number of definitions of a map. A map is a spatial representation of the environment. By representation, we mean something that stands for the environment that it portrays and is both a likeness and a simplified model. The key to this definition for our purposes is that the map is a stand-in for the actual environment. Strategic supply chain maps might simplify the spatial relationships to a great extent, but the essence of the environment must be captured. While a strategic supply chain map must have immediacy, the goal is to exceed our individual reach and exceed our individual vision. The essence of strategy is the communication and implementation of the firm's vision. There are several key advantages to supply chain mapping to link corporate strategy to supply chain strategy, to catalog and distribute key information for survival in a dynamic environment in order to direct the focus of the managers, to offer a basis for supply chain redesign or modification. Current channel dynamics can be displayed in a supply chain map. The process of building the strategic supply chain map in itself will help define the perspective of the supply chain integration effort. 4 issues in supply chain mapping can be recognized: proprietary information, inadvertently changing channel dynamics, getting lost in too many details, providing an ineffective perspective for management use. The types of supply chain mapping are demand density mapping, sales territory mapping, gross margin map, customer DC allocation mapping, isochrones mapping, center of gravity mapping. Let's discuss each. Demand density mapping. This supply chain mapping service provides geocoded customer locations on a digital map that pictorially illustrate geographic demand. This provides insights into distribution management that looking at the numbers alone cannot provide. The size of the customer's symbol on the map can be set at various volume breakpoints. Customers can be mapped based on customer type, customer sales levels, or many other factors as required. Sales territory mapping. Customers better allocated to sales territories and sales staff to better service customers, improve sales resource utilization, assess the impact of entering new territories, assess the impact of new products and services. Gross margin map. Building on the mapping of customers and demand volume, it is possible to map gross margin contribution. This can be done by customer or product group. Use gross margin mapping service to identify high-cost customer locations, identify high-cost product location combinations, establish margin improvement opportunities. This service can also be provided remotely for any location globally. Customer DC allocation mapping. The allocation of customers to be serviced from specific distribution centers DC can often lead to inefficient distribution and higher than necessary costs. The customer allocation mapping process highlights where these allocations can be improved based on the time or distance from the DC. Isochrones mapping. At joint points of equal height above sea level. In this case, it highlights customers a set distance or time from the DC or factory. Our isochrones mapping plots customers based on the travel time or travel distance from the DC that services them. This technique is invaluable in testing different service lead times and what service levels are really achievable. Isochrones mapping can be used to test different service lead times, group customers to logical service locations, assess service options for different regions, indicate the number of service locations required for given service levels. Center of gravity mapping. This supply chain mapping service provides a simple but effective indication of the ideal location for a centralized distribution center. It can be based on the center of gravity of demand, the center of gravity of supply, or the least cost distribution center of gravity. So it can be used to test the location of a DC or a factory, for example. This mapping will help indicate the best location for a facility from a service view, the best location for a facility from a cost view, a range of alternative locations. This simplified model is based on generic warehousing and transport costs, but more detailed network modeling can be undertaken with our customers' actual distribution costs. Now we will discuss the supply chain process restructuring. The supply chain includes the organizations and processes for the acquisition, storage, and sale of raw materials, intermediate products, and finished products. Supply chain product flow is linked by physical, monetary, and information flows. Supply chain management is a term that can mean different things to different people. In the broadest sense, it encompasses all logistic activities, customer-supplier partnership, new product development and introduction, inventory management, and facilities. Processing upstream and downstream experiments in two different steps would imply that some of the upstream mergers in the first experiment would be equivalent to the downstream mergers in the second experiment. We repeat the same mergers-based risk reduction strategies for both unbounded virtualized supply chains and bounded virtualized supply chain with threshold above or equal to 5. The unbounded virtualized supply chain construction computes the maximal length of a VSC as 255. The results are highlighted in the following figures. We depict the whole experiments. No risk management strategy, conglomerate merger, upstream upward vertical merger, and downstream downward vertical merger. Merging with a distributor is less risky than merging with a supplier. While the supplier might increase its prices and alter our profitability by unexpectedly increasing production costs, the distributor's pressure or power of negotiation should be significantly lower. In addition, the supplier could have an increased position on the market, which could limit our options of substituting him with one of its competitors. Supply chain process restructuring involves playing around with at least one of the three dimensions of the supply chain in the direction as postpone the point of differentiation. By moving the point of differentiation as much as possible, a bulk of the activities can be carried out using the aggregate level forecast rather than the variant level forecast. Alter the shape of the value addition curve. Shift the bulk of the cost addition as late as possible. This will reduce the inventory in the chain and also help the RUM in having some flexibility. If the bulk of the cost addition takes place at a later point in time in the chain, one will be in a position to respond to unforeseen changes with the least cost. Advance the customer ordering point. Move from an MTS to a CTO supply chain. By moving the customer ordering point as early as possible, one can carry out the bulk of the activities against an order, which reduces the importance of forecasting. If one were also able to postpone the point of differentiation, one will be able to move from an MIS to a CTO supply chain. In a CFO supply chain, since the point of differentiation takes place after customer order, one does not have to prepare a variant level forecast. Supply chain restructuring is likely to bring in substantial business benefits in general, and in special cases, it fundamentally changes the way in which the supply chain is managed by moving from the MTS to the CTO business model. Do you know the term supply chain management entered the public domain when Keith Oliver, a consultant at Booz Allen Hamilton, used it in an interview for the Financial Times in 1982? Let's know the meaning of postponing the point of differentiation. The concept of the point of differentiation is valid for any organization that is offering a variety of end products to customers. Products are made in a supply chain consisting of multiple stages. As the product moves in the chain progressively, the product assumes an identity that is closer to the end product. The point of differentiation is a stage where the product gets identified as a specific variant of the end product. We will illustrate the concept using a toothpaste manufacturing firm. Let us assume that the firm offers variety only in pack sizes. In such a firm, the packing stage is a point of differentiation. At a packing station, the same basic material, that is toothpaste, is packed in sizes of varying dimensions. So till the packing station, one has been working with the generic material, but at the packing station, the firm has to make an irreversible decision in terms of committing the generic material to a specific product variant. Similarly, at a garment manufacturing firm, at the stitching stage, the firm is committing the fabric to different sizes and styles of garment. In automobile manufacturing firms like Tata, where usually large variety is offered in terms of colors, the painting stage becomes the point of differentiation because at that stage, the firm makes an irreversible decision about the color of the car. In reality, a firm may have multiple points of differentiation. For example, in the case of the garment manufacturer, the fabric dyeing and stitching stages represent two main points of differentiation. At the fabric dyeing stage, the garment firm makes an irreversible decision about color, and at stitching stage, the firm makes an irreversible decision about the style of the garment. Supply chain re-engineering is about analyzing the existing configuration of a supply chain, planning improvements to that configuration, and then putting these improvements into practice. In short, re-engineering is equal to analysis plus planning plus implementation. It is important to recognize that when it comes to re-engineering, there is no magic solution. In the past, companies have often come to regard the latest managerial philosophy, whether it be total quality management, just-in-time, business process re-engineering, or whatever, or the latest technological development, example, materials requirements planning or electronic data interchange, as some kind of silver bullet or panacea. Whilst these management philosophies and technologies all potentially have a role to play, none of them in isolation can ever solve all of our problems. We should also beware of copying solutions which are inappropriate for our businesses. The implementation stages where re-engineering efforts meet the most resistance, and hence it is by far the most difficult one. If we expect that the environment would be conducive to the re-engineering effort, we are sadly mistaken. The question that confronts us would be, if BPR promises such breathtaking results, then why was it not adopted much earlier? We could expect to face all kinds of opposition, from blatantly hostile antagonists to passive adversaries, all of them determined to kill the effort. When so much time and effort is spent on analyzing the current processes, redesigning them and planning the migration, it would indeed be prudent to run a culture change program simultaneously with all the planning and preparation. This would enable the organization to undergo a much more facile transition. But whatever may be the juncture in time that the culture change program may be initiated, it should be rooted in our minds that winning the hearts and minds of everyone involved in the BPR effort is most vital for the success of the effort. Once this has been done, the next step is to develop a transition plan from the as-is to the redesign process. This plan must align the organizational structure, information systems, and the business policies and procedures with the redesign processes. Rapid implementation of the information system that is required to support a re-engineered business process is critical to the success of the BPR project. The IDEF models that were created in the as-is can be mapped to those created during 2B and an initial list of change requirements generated. Additional requirements for the construction of the 2B components can be added and the result organized into a work breakdown structure WBS. Recent developments in BPR software technologies enable automatic migration of these WBS activity relationships into a process modeling environment. The benefit here is that we can now define the causal and time sequential relationships between the activities planned. Using prototyping and simulation techniques, the transition plan is validated and its pilot versions are designed and demonstrated. Training programs for the workers are initiated and the plan is executed in full scale. Supply chain efficiency is one of the most important factors of success for profitable organizations. The goal of the supply chain, in a nutshell, is to keep costs low while maintaining a high level of quality. This is the supply chain manager's conundrum. The more efficiently the supply chain organization can do this, the more effective it will ultimately be in increasing supply chain efficiency. In practical terms, this means creating more agile systems of workflow. Technology is at the forefront of faster demand cycles. The supply chain uses technology to increase the organization's ability to respond to customer orders. If new products are of poor quality or if the current offering costs more than a competitor's products, sales will decline. There are two distinct ways to address these issues: better vendor relationships and increased use of supply chain technology. Now, in the end, let us summarize what we have learned in this lecture. A supply chain map is a graphical representation of supplier network or selected supply chains. Maps can either be geographical or an abstract network design. The supply chain includes the organizations and processes for the acquisition, storage, and sale of raw materials, intermediate products, and finished products. The concept of the point of differentiation is valid for any organization that is offering a variety of end products to customers. Products are made in a supply chain consisting of multiple stages. Supply chain re-engineering is about analyzing the existing configuration of a supply chain, planning improvements to that configuration, and then putting these improvements into practice. Supply chain efficiency is one of the most important factors of success for profitable organizations. The goal of the supply chain, in a nutshell, is to keep costs low while maintaining a high level of quality.